Good morning. Let's get started. First, welcome so much to our first Security Speaker Series event. I'm Mui Landavar. I work on the information security team. Many of you don't know me, but I hope many of you do know Gunjan, our first speaker. Everyone, please give a hand for Gunjan. He's going first. So today, as part of this series, what we're trying to do is bring our own security experts within Palo Alto Networks to come speak. We're hoping to host this event for you once a month, or if there's more speakers and more appetite, about twice a month. And we'll be continuing this in FY20. The idea of the speaker series is to make it memorable and actionable, and to make it fun. So we're providing some food. Someone noticed that it's a lot of sugar in the morning. I'm hoping that's gonna get you pumped up if the coffee doesn't do it, for you to ask questions. And I'd like to entice you to please take the post-event survey. If you complete the post-event survey after I send it out, for those of you in the room as well as anyone who watches the recording, you'll get one of these Beats headphones. I'm hoping that's a cool prize that you will entice you to take the post-event survey. one for each, depending on how budget goes. So as way of a quick introduction to Gunjan, I met him about a year ago in Toastmasters. Recently, I became interested in art, and I'd like to say that Gunjan is like an art piece. He's there, he was created. When you, the viewer, are standing in front of him, it takes some time for you to kind of look at him, turn around, look at him the other way. But within just a few minutes, you'll see that, hey, I'm learning something from him. And that adds to how you are as a person. So I'm hoping for those who know him that you would validate that. But there's so much to learn from Gunjan. He is a perpetual learner, and he likes to teach as well. So I'm holding this up because I recently learned something from him, from his biography, that he likes carrots. So Gunjan, if you do a good job, this is for you. And there was something else in his bio that I had to slack him about. He said he likes to explain technical topics with emojis. And I said, Gunjan, give me an example. And what he told me was, you gotta wait till the presentation. So I'd like to hand it over to Gunjan.
Thanks, Mui. I see you're literally dangling carrots in front of me to motivate me. Hey everyone, my name is Gunjan. I'm a cloud architect in developer relations team. And I have some of my colleagues here. So today I'm going to talk about cloud native landscape. I see there's a lot of technologies that we are using as a company, from virtual machines to containers to serverless. And it's a spectrum of technologies. So I wanted to shed some light on that and also talk a little bit about how security concerns are different for all of them. And at the end, I'll give you something actionable. There's a checklist you can follow if you're using one of these technologies to go back and review your work and see if you're following the security best practices. It's not a complete list, but it's a starting point. So before I start out, I just want to know how many of you are either writing code or QAing code. Okay. How many of you are managing applications in production or pushing applications in production, SRE, DevOps kind of stuff? Okay. And how many of you are management overheads? That's Ivan, he's my boss. Let's make fun of him. He's not a management overhead. He's pretty. All right, so I'll use some silly examples to help you understand this. Just a quick show of hand. How many of you know what containers are? Okay, so most of the room, that's what I was kind of hoping. So let's get started. So pop quiz. Vinay and Anthony back there, you're not allowed to participate. So how many container images do you think we have in our Palo Alto Networks org? Anyone working in InfoSec is disqualified. 6,000. So it's not one of these. I'm just. So whoever gets the number, the closest number, will get this limited edition Kubernetes fidget spinner. I only have 3, so I'm giving you one of the 3s. 5,000. Any other guesses? 10,000. 7,000. 9,000. What's with thousands? Just. No one's getting even closer. Nope. Think bigger.
Outside the box.
No, that's maybe next. All right, you are all right. I think you are the closest, so I'll give this to you, sir. All right, it's 88,153 as of last night. All right, so that was just to make sure you guys are awake. Now, this is where I explain stuff with emojis. Sorry.
You mentioned only the pages or actually the containers management?
No, just images. Okay, so I wanted to explain how this technology, this landscape that we're going to talk about has kind of evolved. Floppy emoji means software, it's code. So people used to start out with some software. You hire some developers, QA, SRE folks to manage it. As you add more features, your software grows, gets bigger. You hire more people. A lot of people are working on the same thing. Your code base written in PHP or something. That doesn't scale. Sometimes, or eventually it's going to catch fire. So someone very smart came up with another alternate architecture many years ago, where instead of doing that one big giant piece of software, you break it down into smaller pieces, smaller chunks. And these have clear boundaries. This thing is just doing payments processing. This thing is just doing sending out emails or something. All these services have different purposes. So break them down, and with a clear concern, clear boundary. And with this, you can also write all those pieces independently, develop them independently using language of your choice. And the key thing about this is you should be able to feed that team with 2 pies of pizza. It's called 2 pizza team. And these things talk on a clearly defined standard interfaces, REST or gRPC. This is called microservices architecture. The one we saw before this, the one that caught fire, was the monolith architecture. One step forward, so there's a new concept of not always on services, event-driven services. Let's say this service that's there, Python service, it's not always needed. So why should we pay for it? Why should we keep it running and pay for it? So it dies or it's sleeping. When another service needs it, says, hey, I need you. It comes back to life, does its thing, and then it will die. Or it just goes to sleep, so you're not paying for it. That's serverless. Yeah.
You said it is in a sleeping state, but if we take the case of like where the web services are being called very frequently, does it take time to bring up and slow down?
Yes. that's why I'll talk about that later, that it's not ideal for everything, and it doesn't replace containers.
Thanks, Gunjan. When we have a question, if you don't mind just repeating the question for the recording. Thank
Okay.
you.
All right. Okay, and throughout this talk, I just wanted to use this metaphor or analogy of food. Some of us are intermittent fasting, I know, so it's hard. So let's think of food. There's 3 ways you can get food at a very high level. One way is to prepare the meal at home. You buy the groceries and prepare all the food by yourself. Another option is meal kit delivery. Has anyone tried Blue Apron or HelloFresh?
I thought about it.
Yes, PJ has thought about it. I tried it for free and then I canceled it. They don't have very good vegetarian options. But what they basically do is they have recipes. You can get like 3 or 4 a week. They pack everything into a box. They send it to you one day. And then you open a box. Everything is neatly packed. It's like you need this much spices. So they will just give you that much spice. You just put that in the food. You cut the food, cook it yourself. And the last option is food delivery. You feel lazy, so you call Uber Eats or DoorDash and get food delivered from Domino's or something. So of all 3 options, this is analogous to monolith, microservices, and serverless. Not one-to-one and not in all aspects, but it will help you understand those concepts. So first one is highly customizable. You can make whatever you want, right? Because you're buying groceries, you're in full control of the whole cycle. But it's lots of work. You have to do a lot of work. Go to grocery stores, do all that stuff. It's time consuming, and it requires more attention. It's more prone to error. If you're not very good at cooking like me, you will end up making something horrible. Second option is let's go to the third one first. Ordering something from Domino's. It's not very customizable, right? You can just ask for pizza. You're not gonna say, put some carrots on my pizza. They're not gonna do that. It's not much work. It's pretty quick. You order in half an hour. It will be at your doorstep. And if someone's messing up, it's their concern, right? If they mess up the food, they will make another one and make sure it's delivered to you. It's not your concern. So a happy medium there is meal delivery kits. I'm not trying to sell this to you, by the way. It's pretty customizable. You can still add some flavor to it if you want. It's packaged, so someone has thought of the recipe. It's opinionated. It's time optimized, and it's also less error prone compared to the home cooked meal option. So customizable is the key point. I made this pizza with popcorn because I make weird food. Try calling Domino's and ask them for this thing. They're not going to do it. So think about it. Customizable, high on that side, low on this side. But speed and agility, high on this side, low on that side. So kind of going back to the evolution, your monolith, big piece of code, goes into microservices, another concept, and to event-driven functions. So this is analogous to what we saw, these 3 things. Okay. And technologies, if you compare technologies that go with this architecture, are virtual machines, bare metal, that go with the first one, containers, Kubernetes with microservices, and for event-driven functions, serverless, FaaS, and again, containers. And we'll see it's a spectrum. So quickly, if someone's not familiar with containers, because it's kind of the key concept, you can compare it with virtual machines, although it's not a fair comparison. A real comparison would be a Linux process to a container. But basically, those are isolated processes running on host. And they don't need the full OS. They share the host kernel. That's a very short of it. So going back to that spectrum, monolith, microservice, serverless, if you wanted to put some products, cloud products there, from Google, you have Compute Engine. Amazon, it's EC2. For microservices part, you have Kubernetes engine from Google, and Amazon EKS, which is just pretty much the analogous service to this one. This is also hosted Kubernetes, but it's from Amazon. Amazon also has their homegrown container orchestrator called ECS. There's also a service from Google called Cloud Run, along with App Engine. So these are kind of in the middle, right? Cloud Run is where you just give it a container and it will run it for you in a serverless fashion. You don't have to manage the cluster. You can if you wanted to. Similar service from Amazon is Fargate. And on the other end of the spectrum, all the way to functions, is, well, Google Cloud Functions and AWS Lambda, where you just provide your code for their runtime environment, and they will make sure to run the code and all of it. You don't have to worry about infrastructure. Use case wise, this is like one line use case. When would you want to use which of these 4 services? So for virtual machines, if you're moving an existing application to cloud, if you had something on-prem, moving it to cloud, virtual machines are a good option there. If you're building a complex microservice-based architecture, complex system, Kubernetes container platform is very good for that. For serverless containers, which is App Engine Flex and Google Cloud Run or Fargate, it's ideal for web backends. If you have a website or mobile website, you want to create a backend for that. And function as a service, serverless, extreme end, is for event-driven task. If you have some one-off task that you need to do based on certain events, you can use that. So as you can see, abstractions also change from that side coming to here, right? When you're working with virtual machines, you're thinking in terms of CPU, memory, network disk, OS, load balancing, networking, all that stuff. As you move to container, you're thinking in terms of services, how these services are going to talk to each other. You're not really thinking too much in terms of where am I going to put this piece of software. Kubernetes container platforms kind of take care of that for you. For serverless, it's again, now it's just your code. You're only worrying about your code and HTTP requests coming in. Because these things invoke based on HTTP requests. Requests come in, they start up, and then, so all these things, by the way, number 2, 3, and 4, most of them use containers in the backend, right? For actual implementation, they use containers. It's the abstraction that is different, and what you are managing is different. So, and the last one for FaaS, you're thinking in terms of task, function, and events. Someone uploads something to S3, and you need to do this thing. So taking the same spectrum across these 4 technology segments. These are some of the things that I put together. It's kind of, subjective, but customization for VMs is higher. It's high to low, going this way. Although I would argue that VMs and container orchestration, you get almost the same level of abstraction, right? You can compare it with how many of you write code in assembly? Oh, you have one person. But most of you are writing code in Java or Python, some high-level language, right? You don't need all the customization. You're not going to write your own code to move some bytes from register to CPU. I don't even know how it works anymore. But so customization is kind of, you don't need a lot of customization. You should be okay with like happy medium. And as we'll see later, that it's not picking one of these technologies, right? Most people will have a combination of these technologies. It's just based on these things, you have to pick which one is good for what use case. So ops, overhead, and tooling, high on this side, low on this side. Developer friendliness on this side, obviously because developers care about code. And with function as a service, they just deploy their code. They don't have to worry about, a lot of other things. Vendor lock-in is high on this side because you're running this as a function. It depends a lot on the cloud provider's other services, like storage, message bus, etc. You can make it vendor independent, but that will, again, defeat the purpose of FaaS. Cost per second. Now think about it. For function as a service and serverless, you're only paying when your service is running, when your code is running. And since these are event-driven, when HTTP request comes in or when someone uploads something to S3, they'll start up. And as I mentioned earlier, it takes some time, so it's not ideal for all the use cases. But you're only paying for that part of when it's invoked. And security responsibility, high to low, again, because cloud provider, in this case, a lot of things fall into cloud provider's boundary. We cannot control how they implement security. We'll see how we can do our part to secure function as a service and serverless infrastructure. Okay, so I'm gonna skip this slide or go through it really quickly. So why containers and serverless? Why are we moving from virtual machines monoliths to this? One key point from my previous slide was developer agility. How fast can your developer iterate? How fast can they be productive, right? If you have monolith app, this is the first iteration, and this is time. Your developers are only happy when they're writing code and they're productive. That's when they're making you money. Rest of the time, they have to set up the environment, deal with installing RPM packages. This works on my machine. Why is it not working on your machine? Sort of problems, right? So they're dealing with all that stuff. They're not coding there. So many years ago, Docker became a thing, right? And so when you hear about a cool new technology, what you do is try it, right? So first option is duct taping your solution to Docker. You put your existing app as is into a container, which is fine. It's not too bad. You're optimizing your code time a little bit because it's packaged and it's reproducible. You take your same software, you can put it on someone else's machine and it's the same environment. They're not gonna say, it doesn't work on my machine, right? Setup and deployment becomes easy. But the ultimate solution, if you have time and you go through the iterations, is to refactor your application into microservice-based applications. Containerize it and put it on Kubernetes or some sort of container orchestration platform. In this case, you have ultimately optimized it. You have a well-defined abstraction. Everything is done as code. Your security is done as code. Your deployment, auto scaling, all of that, developer can just make some changes to YAML file and infrastructure changes without waiting for someone to do it for you. So the ultimate motto is make better use of developers' time. This doesn't mean that ops teams become obsolete, by the way. They still manage the infrastructure, like Kubernetes infrastructure. It's just that they are not so much in the way. So it may seem like the shift is becoming this. A bunch of servers, virtual machines, hundreds of them. As we move from one big monolith to lots of microservices and containerize them, thousands of containers. And if you break it down even further to functions, it's millions of functions. But it's not entirely accurate. People like to think that serverless is the next step, but it's not really the next step. It's going to work with containers. It's going to work with your microservices. And we'll see how using this example of Cared Corp. It's a fictional company. Although I don't know if the name exists, I will have to check. If it does, I'll buy the domain. So this is a very simple e-commerce company. They have a front-end service. They have a cart service, which is basically payment processing service. A product service, which has a product catalog. And then a support service. So if you have a problem with your delivery or something, you need to talk to support or open a case, you click a button. It will take the case notes and then create a case for you. And it has two kind of database. One is like SQL kind database that has customer information and product catalog. And the next one is a NoSQL database, a document store, which has support records. When someone opens a support case with like a long complaint about something, that's in there. And they also have Zendesk, which is, if you're familiar with it, it's like a support system. When you create a support case, it handles that. So at a high level, we're going to work with this architecture, and I'll show you how you can refactor it to move from a monolith architecture to microservice-based and then utilize serverless architecture. So you hear about all these cool things, you go back and decide to refactor. So first attempt at refactoring. What are you going to containerize? Containers are ideal for stateless applications and applications that can scale horizontally, right? It can do stateful applications as well, as we'll see later. But ideally, it's an ideal solution for stateless applications and things that can horizontally scale. Horizontally scale, what I mean by horizontally scale is if you have a lot of requests and one instance of that service is not enough, you clone it, another one, you send half of the service to that one. You keep growing horizontally, you just keep cloning it. So front-end service, payment service, product service, and support service, you containerize all of them and manage it with Kubernetes. You're still keeping the database in a virtual machine. Let's say it's a Windows database. So that's still sitting in a VM. You have containerized the NoSQL database because Kubernetes has this cool new thing called vertical autoscaler, where if you have a lot of requests, it can scale it vertically as well, although not ideal. And Zendesk remains the same because it's a software as a service thing. So this works pretty fine. When on Black Friday, when you start getting a lot of requests, your product service scales horizontally, payment service scales horizontally, same thing with support. And this NoSQL database grows bigger. They're all containerized and talking to each other. Next refactor iteration is identify which components are not always on and can be event driven. So support service is one of the things, right? You're not going to have everyone log into your site and opening support cases all the time, right? And this is Carrot Corp. It's not a big company. It's a small company. People buy fresh carrots from that website. So there's not going to be a lot of support case volume. Doesn't make sense to have a container or a virtual machine or service running all the time to serve, ready to serve this. So this is a good candidate for serverless. So what you do is you make this a function. This is Google Cloud Function logo. When somebody opens a support request, goes to the database and it invokes this service, it wakes up, gets some information, customer information from this database, stores the support request here, and sends the case information to Zendesk. And then after it's done, after it sends an email confirmation back to the customer, it dies. Another case for this would be, let's say it's a US-based company, and at nighttime you don't get a lot of volume. Doesn't make sense to keep services running at nighttime. So this is where you can kind of optimize it, because serverless, there's also a boot up time, right? Even though they use containers, they boot up within seconds. It's not instantaneous. You send a request, something's going to have to boot up or start, and then serve your request, come back. So you can play around with that time and optimize it. Okay, now finally to security. I just want to do a quick time check. Okay. Okay, so many of you must have seen this, right? The stack, and then as we move from data center to virtual machines in cloud, hosted Kubernetes and serverless, the light blue boxes mean they are taken care of by the cloud provider. Dark blue box mean user has to take care of that. Traditionally, security has been enforced at these three layers. I'm talking about traditional security. We have products for the entire stack, Palo Alto Networks. But when you're running VMs in your own data center, VMware, you control the entire stack. So you can put all the enforcement for security you need, and you're responsible for the whole security. For virtual machines, you don't really know what hardware they're going to use, although Google now says they have a Titan chip or something. But you don't control hardware, operating system, which flavors of OS they use, what kind of vetting they do. Network, it's their SDN infrastructure. But again, you can put some controls in place, like putting a firewall, which is needed, but you don't know how their SDN infrastructure works. If it has some problem, it can compromise your system. So you should really take the rest of the stuff that's within your boundary very seriously as we move towards serverless side. So when I think of cloud native security at a very high level, there's three areas that I think about. You have to secure the code pipeline, securing the runtime, and securing the environment where your stuff is running. So what I mean by code pipeline is developer writing code Security starts from there when your developer writes the code. From that point on to your CI/CD pipeline to how your code is delivered, container images, etc. This is securing that half before the things are deployed. That is what we call a shift left. You might have heard of that. We've been using that a lot. Runtime security is where you see like all the exploits, like network security, Bitcoin mining, detecting Bitcoin mining, things like that. That's in this bucket. And environment is securing where your stuff is running. So your cloud environment, if you're on-prem, securing that environment, securing the infrastructure overall. So I'm going to start with serverless security. So for serverless, you're not taking care of most of the infrastructure, right? Kind of like out of sight, out of mind. But it's not really the case. Even so, this is the boundary. When you write an application, your developer writes an application. You have your source code here, users here. They interact with all this stuff that's within AWS's management boundary. You're not managing that. That just means all of this stuff that is within your control becomes more crucial. So one analogy I like to think of is a bank. So we all have a bank account, right? But how many of you actually go and ask the bank, how are they securing your money? Like, is my money safe? Do you know where they're putting your money? But there's stuff that you care about and that is within your control, like your bank login and password. How many of you use ABC123 as your bank password? Vinay, all right. Your Tesla is mine. So when you go to an ATM, you make sure no one's following you, or when you dial the PIN, you're like covering the keyboard, right? So all of those security precautions, they become extremely important. You know that your bank is taking care of your money, but it's still your responsibility when you get out of the car to go to the ATM. After you get the money, it's your responsibility to secure it, right? If it's online, make sure your account doesn't get compromised. You enable two-factor auth and all that stuff. So similarly, in serverless environment, your code and all the stuff you're managing here, all these interactions, you need to make sure 100% you secure those things. So I'll talk about some of those areas now. With serverless, we talk about perimeter, right? Security perimeter. It doesn't disappear. A lot of people say it disappears. It just gets smaller, right? Function is the security perimeter now. Because functions are independent and so are their perimeters. So we need to make sure we validate the input that we get in serverless security. This is just talking about serverless security, by the way. And something like if you're building your own serverless platform, for example, using Knative, which is a serverless platform based on Kubernetes, Twistlock can help with that, right? Twistlock has some capabilities to validate the input before it gets to your containers, your web-facing containers. Vulnerability management. So this doesn't change that much with serverless or containers, because vulnerabilities are vulnerabilities. You're still using packages, they will have vulnerabilities. You need to manage those. But the things that become more crucial in this stack is your code and libraries. So statically scanning your code for vulnerabilities, the libraries, vetting the libraries you're using, and container operating system, all the packages that container has, the base OS you're using, making sure all of them are vetted and you have found vulnerabilities from all the layers and taken care of them. I'm talking about containers in the because Fargate, Google Cloud Run, App Engine Flex, they are you still managing the container, right? Not ultimate function as a service like Lambda, where even in Lambda you're still taking care of the first two. Permission management. This becomes extremely crucial because you don't want your functions or serverless functions to have access to S3 storage, everything that it doesn't need. You need to make sure that is very secure and it's very targeted. You only give those service accounts access to only certain things they need. Because especially serverless, as I said, is kind of used more for web backend. And if you're a web-facing company, if you have a breach, your stock goes down super fast. If one customer is able to access data from another customer, so this happened in 2014, no, a couple of years ago with Steam, the gaming service, right? They had a breach where they had a problem where other people were able to see what games other users were purchasing and their information. So even though it's not, it may not be as damaging, it's important to make sure those things are locked down. For code scanning, there are these three techniques: SAST to DAST. SAST is statically analyzing your code for security testing. DAST is dynamic. So on this side, it's more of white box testing. You're testing your code, binary libraries for vulnerabilities and issues. On this side, it's more of dynamic. When you start your application, we'll try to penetrate, find issues in an actual environment when it's running. The better approach that more people are following is a combination called IAST, securing it, but you're also securing the process from early on, like image scanning, manifest scanning. I forgot what I stands for in IAST. Interactive. Okay, thank you. Okay, container security. So in container security, it is all these things that I talked about for serverless, plus some more things. Because again, it's the same stuff. You're just responsible for more things now. At a very high level, I have done, so this requires another 1 hour talk about container security, but at a high level, these are the 7 areas of container security. If you want a detailed list, I have it on my GitHub here. Build, so securing the code pipeline, network security, east-west. Well, let me talk about that in the next slide. Securing the host where container is running, container runtime, who's managing your containers at the node level. Most people are using Docker. There's CRI-O, Containerd, all those technologies are out there. So securing that technology, orchestrator like Kubernetes, Mesos, ECS, whatever orchestrator you're using, securing that. Cloud environment where this is running, and your data, which is your configuration data, your secrets, where you're actually storing your data. So it's kind of important to explain you what goes into a container image. So you have a container image has a bunch of layers. Typically, those layers have a base OS or base layer, which has the file format of some sort of container, operating system that you're using. Ubuntu, CentOS, Alpine, etc. Then if you have a dynamic language like Python, or if you need Java runtime or Ruby's runtime, runtime dependencies and language runtimes. third-party libraries that your code needs to use. For example, if you're writing code and you're not going to write code to validate phone numbers, it's not your core business. You're importing someone else's library. But that also means you're trusting other people's code. You're using someone's code. You don't know that person. You don't know, you're not vetting the entire code they wrote or the library you're using. And at the end, tip of the iceberg is your code, what your developer writes and the configuration for it. These three things, this is like 90% of the stuff in a container. You don't know who wrote this. So this is why it's really important to scan and validate these two with static code analysis and scan the entire thing for vulnerabilities using something like Twistlock. So Kubernetes security, now this is, again, a very detailed topic, but at a high level, I've kind of identified these 7, this is 7, right? 7, yes. 7 key areas that correlate to 7 side of the Kubernetes logo. Did not make that up. Image security, scanning your images, as well as making sure you use something like binary authorization or notary to validate the image, that this image has been scanned before pulling it from the registry. Network, securing the network, east-west network policies. So Kubernetes has a interface for network policy. Twistlock also does all of that. Service mesh security, using MTLS for container-to-container traffic, service-to-service traffic, as well as creating a higher level policy, layer 7 policies that say this service can only talk to this service on HTTP, this port, it can only do HTTP GET calls, not POST or PUT calls. You can have very specific policies using service mesh. This should be north-south, not northwest. North-south network policies, so traffic coming in from the internet to your service. This is where our VM series firewall can help, as well as Twistlock has some capabilities to validate the input and prevent some sort of attacks like a SQL injection and stuff. Securing the data, secrets management, configuration management. This is where you can use things like Kubernetes secrets and Vault, although Kubernetes secret is not mature enough. So a lot of people use Vault. Storage security, and I have more on storage security on my GitHub. Then isolation is another key thing. Proper user namespaces. When you create a Kubernetes cluster, I've noticed a lot of people just put things in the default namespace. You have to segment it. Even though namespaces by themselves don't provide any isolation, there's things that built on top of that. Like if you create a service that is only for this namespace, it's only for that namespace. Others can't see it. Or when you create network policies, you can isolate those namespaces, PCI compliant, PCI non-compliant, or different tiers or different teams. Preventing things like privileged containers, containers that mount network host, IPC namespace. Those things basically defeat the purpose of using container in the first place. It's just like running the process on the host, and it can see everything if these things are shared. Also, registry isolation is important. Having separate container registry for dev, staging, and prod environment, so it doesn't cross-contaminate. They don't cross-contaminate each other, and a developer doesn't, by mistake, override a production image, and then someone pulls that in production and gets hacked. Next one is behavior. So monitoring the process behavior, what syscalls are going through, what network endpoints it's talking to. This is where Twistlock really shines, monitoring and making sure it's only, let's say this is a storage service, and it shouldn't be making a lot of network calls or any network calls. And it sees that there's network-related system calls being invoked. That's a red flag, right? Or this image had all these things built into it. Now it has a new binary in it, and somebody is executing this binary. It wasn't there when I pulled it from the registry. Why is it there? Why is it executing? So preventing those things. Also, another good recommendation is making your container file system read-only. So once it's built, you shouldn't. You can. There are ways called security context. You can make it read-only, so people or bad people cannot download stuff and run anything from your container. Metasploit, for example, uses a lot of these things, right? Download something. Just enabling that thing, security context, can prevent a lot of attacks. Environment, OS hardening, using operating systems that are optimized for this and that are locked down, like Google's COS, container optimized OS, where the file system is read-only. You can only start containers. You cannot execute anything else except containers. And there's a whole bunch of sandboxing technology out there. gvisor is from Google, which helps isolate containers from each other and containers to the kernel. Since they share the kernel, you don't want them to be able to contaminate the kernel and affect your other applications. Similar concepts apply to Kata containers, Nabla containers. You can use AppArmor, SELinux, all those technologies. And I have detailed slides and information on all these. If you're interested, let me know. And last one is access control. Make sure you have, as I said in serverless slide, all the access control locked down. If some service needs to talk to your Kubernetes API, you create proper service accounts and then audit them and make sure they're not open the whole time. And then Kubernetes also has RBAC for internal services, who can do what, and which service accounts can do what things with Kubernetes resources. So utilize that. And I'm working on putting together GKE security best practices spreadsheet. This is our company internal. So you can go here and check it out, where I put together actual very specific recommendations on what to do and how risky it is if you don't do it. And this is still a work in progress. And I just kind of wanted to show you a reference architecture for how this security can be implemented for a containerized Kubernetes environment. So you have your CI/CD pipeline. As soon as your developer pushes the code, your CI build is kicked off. First one is IAC scanning engine. So we offer this thing from Prisma Public Cloud, where it can scan Kubernetes manifests and tell you what things are misconfigured and which things are highly likely to be exploited. After that passes, you can use Twistlock, using TwistCLI to scan your container images to find vulnerabilities at each layer. Then typically your stuff, your code and infrastructure as code, Terraform, Docker file goes to GitHub, images go to registry, and this is the runtime. So this is the boundary. Everything left of this is shift left. If you prevent it here, you're saving a lot of cost. In runtime, runtime security, network security, east-west, container traffic. Using Twistlock, you can also use VM series. There's a containerized firewall now. And Twistlock can also help with runtime behavior security, as I mentioned previously. So process has kind of changed from the monolith days to now, where dev team used to work in isolation and InfoSec and SRE teams used to work on their own, prepare the infrastructure, provisioning hosts, and all that stuff. And when you're supposed to put things in production, that's when you talk, and it's not very good. So with this, your InfoSec team should be involved early in the process. Start from which base operating systems are you supposed to use. So InfoSec says, okay, these are the 7 InfoSec validated base OSs, only use these, or these packages. So start involving them early in the process, because now all of the infrastructure is running as infrastructure as code. Your Kubernetes, your applications are deployed as code. Your RBAC policy, all of that is in code. So it's not going to be one day when you put things in production, that's when magically things are going to happen. All the folks have to work from early on in the process. And in conclusion, these are the 4 technologies. As I mentioned, these are the use cases. And these are some of the key security concerns that you should think about for each of these technologies. And with that, I have some resources here. As I mentioned, first 2 in the slides. There's also a Kubernetes workshop. I do a 1-day Kubernetes workshop that's recorded, posted here. This is a short version. And if you're interested in doing some exercises, getting some hands-on experience on serverless and container security, I recommend these 2 labs. And yeah, join our Slack channel, training announcement. And if you're interested in Kubernetes certification, we have a study group going for developer and admin certifications. Thank you.
Thank you so much, Gunjan. We really appreciate it. I think we only have time for 1 question. If someone has 1 burning question now, if not, I'll add a field in the post-event survey for you to ask Gunjan questions. Anyone have a quick question right now for Gunjan?
And if you want stickers, I have a whole bunch of stickers here. All these technologies that I talked about.
Okay, great. Thank you so much. Remember to fill out the survey and you'll be entered to win the Beats headphones. Thanks.